anybody else show up?
Nope, just you.
Okay, that's all right. I
Yeah,
figured out how to use the calculator. Thank you very much.
you are welcome. I think this is going to be a shorter one today. It's not going to be like last time that took the whole time. So this is the commutative property. So we've got lots of properties you learn this week, and so this is one of them. So what exactly, when we talk about a property, what does that even mean? It's basically a rule or a characteristic of something. So like a square has the property that all four sides have the same length. So, you know, it's a rule. That's what makes something a square, but it's also, you know, if you look at a square, that's one of the things you can notice about it. So these mathematical properties are just rules that we're following that allow us to do everything with math. Like these are the basic rules that you start with, and then from here we can build tons of different things. So the commutative property, which I'm going to focus on today, I did some research on the history on this because I was actually interested, I was curious. And this was actually named in 1838, but there's demonstration that it was used all the way back in ancient Egypt. It just didn't officially get its name in the 1800s. And the 1800s were sort of when they started standardizing math. And you know, that's where we started getting a lot of the symbols as we learned about this week, is where they started to decide this is the symbol we're going to use. So that was where it actually came up with the name. And so I looked up the word commutative, and this image shows from the Oxford Dictionary that it's coming from Latin, and it's late Middle English, sort of meaning interchanging. But I also found on a different source that said it's coming from French, which means substitute or switch. Now, English borrows a lot of words from Latin, and French is actually based off of Latin. It's a Romance language, so it has the same root as Latin. So I think in the long run, they both ultimately came from Latin. But it basically is the idea that you can change things around, you can switch things around, and that's what the whole idea of the commutative property is. So we have a commutative property for addition, and then one for multiplication, but not subtraction and not division. And basically what the property says is that the order that you add numbers doesn't matter, and the order you multiply doesn't matter. So like 2 plus 4 is the same as 4 plus 2, and 2 times 4 is the same as 4 times 2. But if you try to do that with subtraction, it's not the same, because 2 minus 4 is different from 4 minus 2. They're actually opposite signs. And with division, 2 divided by 4 would give you 1/2, but 4 divided by 2 gives you 2 with the reciprocals. So it doesn't work with subtraction and division. It's only for addition and multiplication. But we can use it for subtraction and division if we rewrite those problems in terms of addition and multiplication. And that's one of the things that I do, at least for all subtraction, is rewrite it as adding a negative, because then you can use these properties and you're less likely to make mistakes when it comes to negative signs, which are very common. So the idea of the commutative property is literally you can just interchange your addition and multiplication and get the same result. So I wanted to start off with these two examples to show you how we work with this with variables, because you're learning how to work with variables. We've got all these different things going on, and also to show the importance of parentheses. So we want to use the commutative property to just rewrite these. And we've got x, and then in parentheses -12, and then y, and then in parentheses -23. So the parentheses are there to make it clear we're not subtracting. If there was no parentheses, we would read this as subtraction. The parentheses are implied multiplication. So this is telling us this is x times -12 and y times -23. Now, when we work with variables, we generally put the numbers in the front and then the variable in the back. So while these are completely valid ways to write an algebraic expression, which is basically just a thing of algebra that's got letters and numbers, we have a convention where the number always goes in front. So we use the commutative property in order to do that. And so you just can rewrite instead as -12 and then the x, and -23 and then the y. Now, when we do this, if the parentheses are in the front, we don't really need them anymore because you've got something times a letter and they're different. A number and a letter are not the same thing. So we usually write this as -12x, and we leave off the parentheses, and -23y. And so this is how we would use the commutative property to rewrite these. And this is the standard form that we write things with variables, where your number is in front, your variable is in the back, and it's implied multiplication. So the -12x is -12 times x. We just don't write that multiplication sign there. It's implied. But the commutative property allows us to take something that's multiplied and write it in our more standard form so that the number's in front. So here's, these actually are subtraction. It's different from the previous because the multiplication had parentheses around those negatives to make it clear that it's multiplication. Here, we don't have those parentheses, so you read it as subtraction. And so I said you can't use the commutative property with subtraction, but we can if we rewrite it as addition. And the general rule is when you're learning algebra, always rewrite your negatives or your subtraction as adding a negative so that you make fewer mistakes with the negative signs and all that. I actually had a student who was with a coworker, and his coworker is like, "Why do you keep rewriting these as negatives?" And he's like, "Well, my teacher told me to." So he stopped doing it, and then he was making a lot of sign errors, and he came back to me. He's like, "Well, I keep making these errors." And I said, "Are you writing as adding negative?" He's like, "No." And I'm like, "You need to do that because that's how you don't make errors with your signs." And when you get really good at algebra, you don't need to do that anymore. And his coworker is probably really good at algebra, and so doesn't need to do that. But when you're learning, it's really important. So that you don't make those sign errors. And it's good to understand the commutative property in terms of things like this, where we've got like x minus 3 or 4p minus 9, because once you get into later things in algebra, like when in the second half of the class, when we start doing stuff with factoring, you may see these written in opposite, like instead of x minus 3 might be 3 minus x. And we like to have our variables as the first thing when we do factoring. So you have to rewrite it. So you have to be able to use the commutative property to rewrite your things so that they're in the standard form that makes the rest of the work easier. So in general, we like to have the variables first. In this case, in both of these examples, the variable is first, but we're going to use the commutative property to show you how you can write it the other way. So first thing is, subtraction is defined as adding a negative. So we use that definition of subtraction so that we can rewrite these. So instead of x minus 3, it'd be x plus -3. And then we have 4p plus -9. So that's just the definition. The mathematical definition of subtraction is adding a negative. Now we've turned it into addition, so now we can use the commutative property because the order doesn't matter. So we're going to flip-flop the order of the addition because now we've turned it to addition. So that means we have -3 plus x and -9 plus 4p. And so we just used the commutative property to rewrite these. But we had to first take the subtraction and make it adding a negative. And this makes it very clear when you're working with variables that any subtraction, that is really a negative sign going with the thing that's after it. And that's really important because that's where people mess up, is they see subtraction, they don't realize it actually means a negative. So like they see x minus 3 and they think it's 3, but it's actually -3. So rewriting these things like this can make it easier so you can see, oh, that's actually a negative, and it's going to be helpful further down the road when we do something called factoring. So here are a couple more with actual numbers, and you can see where using this might be useful, or it is another way to kind of look at these problems. So we have -5 minus 7. So if we use the commutative property to rewrite this, we've got subtracting 7. Now, a lot of people get confused once you start doing subtraction and you've got negatives involved. A lot of people struggle doing that in their head. But it can actually sort of help to maybe use the commutative property or rewrite this. It might maybe make it a little bit easier for you. So first, with the -5 minus 7, we're going to turn the minus into adding a -7. And so we've got -5 plus -7. So let's say you're trying to do this in your head. For some reason, I look at this in my head and I'm like, oh man, how do I subtract 7 to -5? Or you can think of it when you're adding, you've got two negatives, you add the numbers and then your answer's negative. So I'd be like, okay, 5 plus 7. But for whatever reason, the way that my head works, if we use the commutative property, we could rearrange those and have -7 plus -5. And so this is actually easier for me to do mentally for whatever reason, is if I'm looking at -7 plus -5, I'm like, oh, 7 plus 5 is 12. But for some reason, 5 plus 7 doesn't automatically think 12 to me in my head. So I don't know why, but it's easier for me mentally to do it in one way versus the other way. So that's one, that's how you can use the commutative property, especially if you're trying to do math mentally, is you can rearrange things, change the order, and then maybe for whatever reason, it's easier to do that in your head than the other way. Now, this says just use the commutative property to rewrite. So that's all we're literally doing is rewriting it. We're not simplifying it. We're not actually doing the addition here. We're just rewriting it just to show you what that commutative property means and how it can be used. Now on the right, I've got a division problem. So I said you can't use the commutative property with division because the order matters. Well, in order to use the commutative property, you have to rewrite it as multiplication first. So we go back to the rules of fractions. If you divide by a fraction, you multiply by the reciprocal. The rule for division is when you're dividing, you're literally multiplying by the reciprocal. That's defined. Division is defined as multiplication of something else, which is the reciprocal. So the way to think about this problem so that we can use the commutative property is first you write 2 as a fraction. And any whole number written as a fraction is 2 over 1. And then we can turn that into multiplication by taking the reciprocal of 2. So that's 10 times 1/2. Now, always use the dot for multiplication because when we're dealing with algebra, we're dealing with the letter x. And so you don't want your x's for your times symbol to look like the x of a variable. So we use the dot instead. So you're going to want to get used to using a dot instead of the x for multiplication, or things just look very confusing. So now I've got 10 times 1/2, and that's basically dividing by 2 is the same thing as multiplying by 1/2, and that's important to understand here. So we're going to use the commutative property because all we did was rewrite it as a multiplication. We haven't actually used the multiplication property yet. And so the commutative property, I think I said multiplication property, the commutative property, we haven't used that yet. And to use it, we're going to change the order. So we're going to flip-flop the 10 and the 1/2. And so this is the same thing as 1/2 times 10. So using this commutative property and realizing that dividing by something is actually the same as multiplying by like a fraction, that can kind of help you understand fractions better and get used to fractions. Like if you look at this and you say, what's 1/2 10? Oh, that's 5. And then you look at the other way, 10 divided by 2, that's 5. You can see that there is a relationship between there. If you did 10 times 1/2, that might not mentally make as much sense as, say, 1/2 of 10. You know, so even the order of that multiplication there makes more sense in one order than it does in the other way, even though they do mean literally the same thing. So the commutative property is useful, especially when you're learning algebra and you're looking at it and you're like, this doesn't make sense. Try using the commutative property to see if it makes sense in another order. You know, if flip-flopping it makes sense. And then you might be like, oh, I see exactly what's going on. Are there any questions so far?
I have a question.
Go ahead.
I think I probably did it the long way around, maybe, but I took the 10, instead of doing 10 as a whole number divided by 2, I put them both as fractions, 10 over 1 divided by 2 over 1, so that I could flip them and multiply them. Is that just the long way around, or is that an error?
Writing 10 over 1 is completely fine. You don't have to turn that one into a fraction. If we were to actually multiply this out and do the 1/2 times 10, yeah, you'd want to write 10 as a fraction because it just makes it easier. But since we're just rewriting and we're not actually doing the multiplication, it really doesn't matter. So
Okay.
that could be the long way around. But whatever you're comfortable with, they're equivalent. They mean the same thing.
Awesome. Thanks.
So if there are no other questions, I've got 2 more examples of where this could be helpful or useful. So we're going to use the commutative property to add all the numbers 1 through 10. Now this actually comes from Friedrich Gauss. He's a mathematician from, I think it was the 1800s, could be 1700s, but he is famously in math circles, famously known. And when he was a kid, apparently the story goes that his teacher was fed up with him or something, and so told him to add the numbers 1 through 100, thinking that it would just keep him busy and he wouldn't like cause problems. Well, he found a shortcut to doing so and was able to come up with the answer very quickly, much quicker than she thought. And so we're going to do that same shortcut here using the commutative property, so you can see how if you use these properties in just the right way, it can make things easier for you to do the math. Because sure, you can pull out a calculator here and just add these up on a calculator. But let's say, you know, you're back in his day and you didn't have a calculator and you had to do it all by hand. You know, at first it seems kind of easy. Okay, 1 plus 2 is 3, 3 plus 3. You know, you can go on, but then you start getting into larger numbers and it's harder to do mentally. And say, if you really are adding 1 through 100, you're going to get, you know, let's say you got to do like 98 plus 99 or whatever. It's like, oh gosh, I can't do that in my head. So here's how we're going to use the commutative property. So it says that you can rearrange the order of things, and all of our examples have had 2 things multiplied together or 2 things added together, but you can essentially do it with any number of things added together because you're basically just interchanging. So you can, like, I could move that 10 from the back all the way to the front by just flip-flopping numbers. Like if you actually had physical numbers, you're just kind of, you know, swapping them back and forth. So what Gauss did, and so he's like, okay, I'm going to start with 10. And then he started grouping numbers that in pairs added up to 10. So like the 1 and the 9, those can be grouped together and that adds up to 10. And so I can even, so I keep track of my numbers here. We've used 3 of them. And then, okay, let's do 2 and 8. And then, okay, 3 plus 7. And then 4 plus 6. And then we've got the number 5. And he basically did this for all the numbers 1 through 100. But if you do it with a small set, you can actually see the pattern, and then you kind of figure out, oh, this is what the answer is going to be if you add these up to 100. But this actually made it a lot easier for him to do this math in his head, because he, instead of going literally left to right, and that can take a long time, if you group it into things that add up to 10, it's super easy to count by tens. So you can see, oh, I've got 5 sets of 10 here plus 5, and so this adds up to 55. And so he did the same sort of thing for the numbers 1 through 100. So if you think of the pattern here, we had 5 sets of 10 plus 5, and that was the numbers 1 through 10. 5 is half of 10, so you can make a guess. Well, 1 through 100, half of 100 is 50. Add 5. No, that's not going to work. 50 times 10, because 5 sets of 10. So 50 times 10 is 500 plus 5, and then you can say, oh, I think the numbers 1 through 100 are going to add up to 505. You can see a pattern here. I actually don't know what the numbers 1 through 100 add up to. I haven't actually done that. I think there's a formula actually for it. And I probably did my math 50 times 10. I don't know. Well, I probably did my math where I'm trying to do it mentally. I'm not Gauss. He's like a genius. But the whole point of this is to show how you can use the commutative property to rearrange your numbers, and then it makes it easier. Christy, yeah, 5,050. So I did my mental math wrong. I used my formula that I know, and that also gave me 5,050. So clearly, you might want to have to go through 1 through 20 to really see the pattern here. But he was much smarter than I am. But this is, the commutative property used well and used in the right way can actually help you do your math mentally faster than if you literally try to add all of these left to right. It's one of the tricks of mental math. And you know, if you do it this way and you don't spend your time writing it down, you might even be faster than typing it into a calculator. There any other comments or questions about this example? Okay, so this is my last example. So this is more of a real world situation. So in third quarter of a football game, a quarterback made a 5-yard gain, a 2-yard gain, a 10-yard loss, and then a 4-yard gain. So this would be, you know, this happens. And let's say you want to know what the total net gain or net loss is. So first we're going to actually write down what the actual movement was so that we know where the quarterback is moving. And then part B is to actually add those up. And we're going to use the commutative property to make it a little bit easier mentally to be able to do that. So for part A, got a 5-yard gain, so that's going to be a positive 5. And then a 2-yard gain. Then a 10-yard loss, so that's subtracting 10. Or you can think of it as adding a negative 10, so a loss would be considered a negative number. And then we have a 4-yard gain. So looking at this, okay, 5 plus 2, 7, that's easy enough. But then you have to go to a negative 10, and then you're adding 4, and then that's maybe not as easy to do in your head. Part B, we're going to use the commutative property. So you're going to want to rearrange these numbers in a way that makes it easier for you in your head. Now, everybody has, you know, a different ability as their mental math ability, what numbers they know really well to add together. So you may rearrange this differently, but I look at this and I think, well, let me do all the positive stuff first and then take care of the negative, because the negative 10 or just subtracting 10, that's easy to do. So let's add first and then do the minus 10 versus doing adding, then subtracting, and then adding again. So I personally would rearrange this so that I have the plus 4 first and then do the negative 10. Just mentally, that would be easier for me. And so then 5 plus 2 is 7, plus 4, And maybe 7 plus 4 is not something that you do easily in your head, but maybe you can do 5 plus 4 easily and then you add 2. Because it's all about what mentally kind of works for you. So like 5 plus 4 is 9, 9 plus 2 is 11. That seems a little bit easier for me than maybe 7 plus 4. So you could do that, and then you basically have 11 plus a negative 10, or basically 11 minus 10, and then that gets you 1 yard, basically, and that's a gain. Yard gain because it's positive. So, I mean, you would be doing this maybe mentally in your head. You wouldn't be writing down all of these steps, but otherwise it'd be like, if you do it exactly as written, 5 plus 2, 7 minus 10, okay, that's a negative 3, and then plus 4, and it's like, oh, okay, that's 1. It just seems a little harder mentally. So the commutative property, we use it for it's used in algebra to rewrite things, but it's also great for mental math so that you can add together, and you can add things in any order, so that allows you to group the numbers that you can add easily and then go from there. So Christy, you're saying solitaire, you count to 11s automatically. Yeah, I'm a lot better counting to 11s. I definitely play cards quite a bit, so I think that's why the 9 plus 2 is easier for me versus the 7 plus 4, although 7 plus 4 is still adding to 11. I don't know, 9 plus 2 just seems a little bit easier. Maybe it's just because adding by 2s is simple. But that's the whole point here. So we've got this commutative property, and we're going to be using it, and we do use it to rewrite these things with numbers, and this is why we put the number in front and how you're allowed to work with it. But this also allows you to read things with negatives differently, and it allows you to find alternate ways to look at the numbers that make more sense to you mentally. And if it makes more sense to you mentally, then you can spend that mental power on something else, versus spending all your time trying to figure out what this means or trying to do this math and going in the order that we have. If you can make it easier on yourself here by rewriting the numbers, then that allows you more brain power for something else that might be a little harder. So that's the commutative property. We have tons of other properties. I have a video on the distributive property. We've got the associative property. There's a whole bunch of different properties, but you want to use them to your advantage so that they make your life easier. That's the whole reason that they're here. And then Christy, I find making a minus into a negative addition, it's easier. I completely agree, because trying to subtract negatives, like if you had 3 minus 10, it's just harder to do mentally. But if you think of it as 3 plus a negative 10, once you kind of understand how those negatives work, it does seem easier. Especially a negative minus a negative is a lot easier to think about if you have it a negative minus a whole number. Like let me go back to it, like negative 5 minus 7. I find it a lot easier to do it mentally if I turn that into adding a negative 7. Whichever way your brain works, but you want to use the way your brain works to your advantage in addition with these properties, because it'll make things easier for you. It'll be faster, and you get better at mental math, which is always doing anything mentally is always good for you to get your brain working. So are there any questions?